Today I'm going to discuss the allowable strength design or working stress method of designing a reinforced concrete beam based on eStructural Design Taichi found on the App Store. The input parameters required to design a simple or cantilever beam are as follows. Name of beam like B1, G1, CB1, width of beam, depth of beam, length of beam, size and grade of main bars, size and grade of stirrup bars, the strength of concrete used, and design loads, which includes uniform load and concentrated load. Given the FC prime and FS, solve the balance section properties of the reinforced concrete design like N, the modular ratio of elasticity, K, the height of the neutral axis expressed as fraction of the effective depth, J, the length of internal moment arm expressed as fraction of the effective depth, and R, the factor for resisting moment in concrete. Determine the design load of our beam, whether uniform load only or combination of uniform and concentrated loads. Uniform loads consist of self-weight of beam and load from floor slab, while the concentrated loads can be evaluated through beam analysis. After we gather the input parameters, derive balance section properties, and determine the design loads, we can now solve for M sub W, bending moment from uniform load, M sub P, bending moment from concentrated loads, if any, then get the total moment and solve the effective depth and total depth of beam. For singly reinforced beam, we solve the area of steel required based on the moment and effective depth, and after that derive the number of bars on the tension side and the compression side. And for doubly reinforced beam, the moment from the assumed section should be less than the total bending moment capacity required for our beam design. Solve the following moments. M sub 1, bending moment of given section. M sub 2, additional moment required in excess of the given section. Next, solve the area of steel required for each moment and sum them up to get the total area of steel that satisfies the design moment with our given section. Then solve the number of bars for the tension side. As for compression bars, solve the stress in compression steel reinforcement Fs prime and compare it to the stress in steel reinforcement Fs, then select the smaller value between the two and set that as the final Fs. Then solve the area of compression steel required and its equivalent number of bars. Test the shear stress and bond stress of our design against the shear and bond stress capacity of concrete, and proceed to web or stirrup design. For the evaluation of stirrup design, case 1 is where the shear stress does not exceed the shear stress capacity of concrete. Therefore, follow the slide for the spacing of stirrups. We use case 2 when the design shear stress is greater than the shear stress capacity of concrete. Refer to web diagram from previous slide to check the web stress. When the spacing of stirrups SP is greater than or equal to our specified SP max, which is 10 inches, refer to current slide for final spacing of stirrups. When the design shear stress is greater than the shear stress capacity of concrete, and after checking the web stress, the spacing of stirrups is less than the specified maximum stirrup spacing, follow the steps in case 3. Group 1. Use a single 2 inches as initial spacing away from a face of support. Group 2. Iterates the web stress procedure until the spacing of stirrups is greater than or equal to 6 inches. Use that number of iterations for 4 inches spacing. Group 3. Continue to check for web stresses until the spacing of stirrups is greater than or equal to maximum stirrup spacing. Use the number of iterations for 6 inches spacing. Group 4. As for the final check of web stress, be sure that the spacing of stirrups is greater than maximum stirrup spacing and designate that as rest at maximum spacing. Follow the simple beam and cantilever beam format below. Simple beam. Design criteria. Beam size includes width, depth, and length. Main bars with grade that includes size and number of top bars, stiffener bars, and bottom bars of both support section and center section. Stirrups with number of legs, size, and grade, spacing from case 1, 2, or 3 of our design. Cantilever beam is the same as simple beam, but without the center section. Stiffener bar guide for different sizes of main bars used for design. Thank you for watching. Please like, share, and subscribe to our channel.